So green and blue, if you can just pay attention, please. Ellen, if you just keep going on with your stuff, you're learning. Right. So green and blue, pens and pencils down. Maybe shut your screens for a minute. I'm just going to go through the cylinders, okay? And I do have a cylinder here, so we'll pass that around in a minute. But there's three versions of your cylinder that you can be looking at. One type of cylinder and formula has no ends, one has one end, and one has two ends. So this is like your aluminium can, yeah, that you drink out of, okay? And what the formula equates to is, for example, if we start here, I think is the best place to start. Our area for a circle is pi r squared, yeah? Okay, so this is what you have here, pi r squared, and that's your formula for the area of this surface here. Okay, now of course you've got another surface there making two of them, which is where that 2 comes in. Alright, so none of these formulas hopefully will be too unfamiliar to you, because you, whether you do or whether you don't, you should know pi r squared is the area formula for a circle. Okay, and so that's that bit there. So by the time we've calculated that, all we have left is this curved surface. Yeah, this curved surface here that I'm pointing to. Now when we unravel that curved surface, essentially you're left with that. Yeah? Alright? And they are telling you that if you are to use that, you will find the area of that curved surface. 2 multiplied by pi, multiplied by the radius, multiplied by the height. Okay? This equation is the same, except what is dropped off, Luke?
One end.
One end, and so how does the equation change?
No.
Yep, have a look at the equations up here. How do they change?
Oh, there's no 2 on the...
Excellent. Good persisting with your learning. There's no 2 here, is there? Okay, there's 2 there because we had an end and we had an end. We only have one end. This is hollow, so this is open. This is closed. This would be like, I don't know, a 44-gallon drum. Often they're open at the top, yeah? Closed at the bottom. What else can you think of that might be an example?
Bin.
A bin. Excellent. What was the other one? No? Pringles. Packet of Pringles. We're dishing our hand in there. That's right. So the pi r squared relates to the black. Okay. Which leaves the 2 pi r h to again be this curved surface. Okay. So this part is calculated by doing that calculation there. And the final one, with no ends at all, just a cylinder. What's an example of maybe that, Isaac? What's an example of a hollow-ended cylinder?
Piece of pipe.
A piece of pipe is a classic, all right? A pipeline, yep.
Toilet roll.
Toilet roll is another one, okay? Hollow through the middle. So what drops away? This drops away. This drops away completely. There is no need because there's no surface there. Yeah, because we're calculating, Caitlin, we're calculating the surface area. This does not exist. There is no surface in which to calculate. All you're left calculating is the curved surface in total, okay, which is the 2 pi r h. I could make you try and memorise them because I don't think they're terribly difficult. However, I don't go around in my life as an adult having memorised those as a student and going, oh yeah, there's a bit of pipe, I'm going to go measure that. All right? I don't really go do that surprisingly very often. So you will be given those formulas. Again, like in the test, you'll be asked to know how to use them. All right? And that's the important part of this practice. Remember, this is practice for game day. Game day is your directed investigation. Game days if you work with pipe in your life. Or maybe toilet rolls. Okay. Are there any, can I explain that better for anybody? Understand that? Obviously your R is the the distance through here, and your h is the height. Not always going to be that easily seen. You might have to do some manipulation of numbers to try and find those things. But basically all you're trying to find in this is an r for radius and an h. Sometimes you'll be given the diameter. That might throw you a bit. All right, so just be aware of that. Okay. So we're going to go through Pythagoras' theorem. All right, we're going to go through it a little bit slowly, but what this allows you to do is also look back over it. Okay, see? So Pythagoras' theorem is applied to triangles which have what we know as a right angle in them. Okay? How many degrees in a right angle? Can you watch this? It's 90 degrees, that's right. Okay, and we can do it with this triangle as well, guys. Alan as well, because this too, you know, apart from that little mess up there, this too has a 90-degree angle in it. So we can do Pythagoras' theorem with any triangle that has a 90-degree angle in it. Okay? Now, there's a few terms that I want you to become familiar with. Okay? One term is called the hypotenuse. Okay? And the hypotenuse is the longest side in any right-angled triangle. Does that make sense? In any right-angled triangle. Because you can only do Pythagoras' theorem with right-angled triangles. Okay? And so the hypotenuse is always the longest side, and the hypotenuse, if I just rub that out for a sec, the hypotenuse is always, if this is your eye, and I'm no artist I'm afraid, but if that's your eye, there's your eyelashes, okay, if you're looking from in behind that right angle, I'll leave this all up here, if you're looking in behind that right angle, and looking in behind that right angle, your longest side is that one there. Your longest side is opposite that right angle. Okay? Does that make sense? It's always opposite. So if I had a triangle which looks like this, sorry, get there in a minute. If I had a triangle which looked like that, that's my 90 degrees. I put my eye in behind there, and even draw it if you have to. That's what I'd suggest. Your opposite of that is your hypotenuse. That's your longest side. Okay? We all right with that? Okay. Now, we use Pythagoras' theorem in triangles where we don't know a particular side length, where we might know 2 side lengths, but we don't know the third. Okay, so this is always used when we know 2 side lengths but not the third. Here's the example. This is 3 centimetres, this is 4 centimetres, but this, we don't know how many centimetres that is. Okay? And this is how we go about it. Let's propose for a minute. We're going to set up what the theory looks like. And the theory looks like this. A, B, and C being your longest side. Okay, C your longest side. If we square C, that will equal the square of A plus the square of B. Okay, it'll always do that. If it's a right-angled triangle, the square of the 2 shorter sides will always equal the square of the longest side. Okay, so that is a rule that we always know. And how we set this up, folks, for this is always by doing C squared equals A squared plus B squared. It lets your person know that's marking your work that you know you're using Pythagoras' theorem. So always start with this. Just like we have been with shapes, we're doing area equals length times width, yeah? Okay. What's our C on this occasion? It's always our hypotenuse. What's our C length? What's our C length in this triangle? What's our C length, Sam?
7.
It's what we don't know, isn't it? C is our hypotenuse. If we put our eye behind here, that's our hypotenuse there. So we're going to leave it as C. We don't know what it is. We could call it X, we could call it oranges, we could call it whatever, but we don't know what it is. Okay. Do we know A?
Yeah.
What could it be?
3.
It could be 3, it could be 4. Sam's called it 3. Let's go with 3. And what therefore must be B?
4.
It must be 4, that's right, 4 squared. Now remember that 3 squared is not, it is not 3 times 2. Okay? 3 squared is 3 times 3. Yeah? Okay? 16 squared is 16 times 16. It's not 16 times 2. Alright, so don't make that common habit problem. C squared equals 3 squared. 3 3s are 9 plus.
8.
You've made a mistake. Good try.
16.
What is it?
16.
Good recovery. Well done, well done. Mistakes are great as long as we learn from them. 4 4s are 16. C squared therefore equals 25. Now this is C. We want to get C on its own, but we don't have C on its own. We have this nagging little square up here. What's the opposite to addition?
Subtraction.
What's the opposite to divide?
Multiplication.
The opposite to squaring is to square root. Okay? You'll see it on your calculator. Therefore, because we square rooted this side to get rid of this, we must square root this side. Okay? What we do to one side, we must do to the other. So this gets rid of this, so we're left with C. That's what we wanted. We wanted C on its own. Yeah? The square root of 25 is 5 centimetres. We've now found the unknown is 5 centimetres. You guessed at the start about 7. It's actually 5. Okay? Okay, so what we want to go through now is the example where we don't know one of the shorter sides, but we do know the longest side. Okay, so we're going to give this a crack here, where we know that this is 10 centimetres, which is this longest side, and we know that this is 6 centimetres. What we don't know is this here. Alright, so again we start with Pythagoras' theorem. A squared equals B squared, A squared plus B squared, sorry, will equal C squared. Alright? What is C, Ellen, on this occasion? What's C? What's C? Have a look. C is our hypotenuse. Hypotenuse is our longest side. Excellent, good correction, okay? 10 centimetres is our hypotenuse. And what's our A? Could be 6, absolutely, 6 centimetres. What's our B, Sam? Unknown, we don't know what it is. 10 squared, 10 times 10. Good. Is 100 equals 6 squared. 36. 6 6 is a 36, your place, equals B squared. Okay, now this is where it comes in a bit tricky. Not too much. But again, remember when we went, what we did on one side, we did to the other? Okay? We want to get B on its own, and to get B on its own, we've got to get rid of this, and we've got to get rid of this. Okay? We do one at a time. We get rid of this first, the number first. So how can we get rid of 36 things? What's the opposite to having a plus 36 there? Take it. Yeah, subtract it. Let's take 36 from there, but what we do to one side, we must do to the other. So we must take 36 from the 100.